Okay, welcome everybody to week 3 of our MIS class. And this week we're going to talk about one of the foundation and one of the infrastructures that we need for information system to build an information system, and in order to use it and in order to help us to have an efficient business process uh, through our business activities. So this chapter, as you can see here, this chapter is going to discuss the role of database for managing a firm's data and providing the foundation for business intelligence. Chapter name is Foundation of Business Intelligence, Database and Information Management. So we have some objectives. Here there is some objective for today's lecture. Describe how the problems of managing data resources in a traditional file environment are solved by a database management system. Describe the capabilities and value of a database management system. Apply important database design principles. Evaluate tools and technologies for accessing information from databases to improve business performance and decision making. Assess the role of information policy, data administration, and data quality assurance in the management of firms' data resources. These are some adjectives for today's class. So, first of all, before talking any more about the database, I want you to share with me if you have any experience in database, any database that you have been used so far, and maybe some website at your workplace or any kind of database you have encountered or you have been used. I like you to share your experience with the class, with me and with your friends. If any, please raise your hand. I pass you the mic and we'll learn from your experience. If anybody wanna talk about any experience in database area before starting the lecture, I can pass you the mic and you can share your experience with the class. So it seems there is no experience in database area, or you may not wanna share your experience with us. Okay, by the way, I'm continuing. So the first thing that is important in this chapter is, first of all, you need to know from the base how the files created, how the data collected, and finally how we reach to the database. There is some actually some concepts here. We can say file organization and concept. So actually for a database to be effective and to be efficient, information system is a necessity to provide users with some accurate, timely, and relevant information. Please turn off your microphone during the class. Thank you. Can you please turn off your microphone? Okay, I turn it off. Mr. Abdul Samad, please keep your mic off. Thank you. Mr. Abdul Samad Nazari, please turn your mic off.
The mic بتونجي off كده تقدر.
So we said for a database to be efficient, actually an information system needs to provide users with accurate, timely, and relevant information. When we say accurate, we mean free of error. When we say timely, we mean actually available to decision making when it is needed, and relevant means useful and appropriate for the types of works or any kind of activity that the decision making require it. In some information systems, and data have been poorly organized and manipulated that cause some problems, and we need to have a database to actually organize and collect our data in the way that we can use in our business processes and help us for our organization, our company to control everything, to control the data flow and any kind of process in our company. So for these things, at first we need to have some concepts and understand the basement of database. Here you can see we start from field, record, file, and then reach to database. Actually, as you know, in computer we have bits, which is 0 or 1, and after that we can some of the bits make byte make character, and some of the characters which makes a word or number, we call it field in a database. And groups of related fields make a record for us, and group of records make a file, and finally groups of files can make a database. Actually, later on we'll bring some example and make everything more clear for you. For now, you need to know when we say record, record is talking about an entity and describe an entity. Entity in database can be a person, a place, a thing, which we need to store some information about. And any entity needs to have actually have some attributes, some characteristics or quality, or describing entity. Actually, attribute describe the entity by some specific characteristics. For example, here we have attributes date or grade belong to entity course. Imagine in our database, for example, it's the university database, we have some fields for any of our records. Our records can be our students. Any students have some fields, for example, name, family, address, telephone number, something like this. These are fields make a record for a student. Some of our record. For example, we can say year one student, year two student, make some file, and the overall university profile of a student can make a database for us. So in this database, we have some entity. Entity, for example, students. A student is an entity, and any course, any lecturer, buildings, all of these uh, can be entity for us in this example. And any entity have some attributes. For example, here we take the course as an entity. A course has some attributes like date or grade. For any student, this course showing that they have a date for taking this course or they have a grade for this course, something like this. In another example, here you can see by more detail. Here is bit, can be 0 or 1. Then we have byte, we have field. You can see here, for example, our field is a course IS101 is a course name. We have a record, a student ID, course, date, grade. For example, a student with this ID take this course at this date, and this is the grade, the result. So here we have few students. For example, in this example, 3 students take this course, and this one make a file for us. And what is database? Database is here. We have 3 files here. For example, personal file, financial file, and course file. All together make a database for us. So this graph shows the data hierarchy. You can see from a bit to a database. So as you can see here, this helps us to actually organize and collect our data in such a way that we can use it for further activity, analyzing, or any kind of things that later on we talk about it. So, but before database, actually, in a traditional file environment, there was some sort of problems. Why? Actually, when the database built and created, it was because of that sort of problems. Databases emerged to in order to solve this kind of problems. We can categorize the problems here in the traditional model. When we say traditional model, you can see here in this slide, traditional file processing. As you can see here, in different departments, for example, in accounting and finance, or in human resource, sales and marketing, manufacturing, we had different user and different application. For example, application 1, 2, 3, 4 here. And we have derivative files. We have different files here. Okay, everything is collected but separately. In any department, we have different application and different files. Everything is separate. We cannot control everything separately put in the system. It's not centralized. It's not like a database and centralized. So this kind of architecture, this kind of traditional architecture of file environment have some sort of problems. These problems can be categorized as data redundancy and inconsistency, problem data dependency, lack of flexibility, poor security, lack of data sharing, and availability. When we say, for example, data redundancy, we mean actually duplicate. Uh, Redundancy means we duplicate data in multiple data files. For example, in different systems, we have to have some things. Uh, for example, in different departments, we put the same data, so we duplicate the data. Some data actually save in more than one places. We need some sort of data. We need to store them in the different systems separately, or in consistency. For example, some attributes may have different values. When we say consistency, for example, we have some kind of attributes. For example, we had attribute grade for a course. This one can have different values in different systems. So this one is a kind of problem. Or program and data dependency. In the traditional model, actually, the programs maybe uh, provide with data separately. So if there is some changes in one program, and the other also need to be changed, or the data need to be changed, so they are not related and they are not dependent. Uh, have some problem in to connection between programs and data, especially when there is some changing. And so as a result, we have a lack of flexibility. You know, uh, in the traditional environment, everything is routine, predefined, fixed, and scheduled already. So in case of any ad hoc activity or emerging any kind of problem, the system is not flexible. Um, the of course, we put so much effort, we did so many programming, but the system is not um, centralized, so it's not flexible to handle the different situations, to handle the difficulties and such thing. And the other problem is security, poor security actually. And there is little control or management of data, or accessing or dissemination of information uh, may out of control. Uh, it's very poor in security. And the other thing is lack of data sharing and availability. I already told that different pieces of information in different files and different part of an organization. So everything is separate. So we cannot relate these things easily together. So sharing of information, sharing of knowledge through our organization is impossible. Actually, uh, is impossible in a timely manner. You can do something, we can share something, but in this era of business economy, we need to do everything on time and timely manner. But in traditional file environment, it's impossible. Different function in the business. Uh, when we say different function, we means, for example, in accounting department, in finance, in HR, in marketing, different actually function in our business maintain their own separate files and databases. Everything is separately managed, but we need to get all these things together. So here you see these things. I think before going to talk about database and database management system and these things, we may need to have some practice, some more practice on the these things, maybe entity, attributes, and their relationship in a database is not completely clear for you. So as a result, I put an extra file, actually a tutorial file here to have some more practice and some more example on this in these things, and may help to find the entities better. As you see here in this slide, we said entity can be a person, a place, a thing on which we store information. So anything that in our database we need to store information about it is an entity for us. So I bring this tutorial here. We have some example. I want you all to read this part and try to find uh, some entity, at least 4 entity, 5 entity. I give you some time and I want you to find some entity in this example. I can read it for you, and I want you all to right now find some entity. For example, this example is about the publishing company. A publishing company produces uh, scientific books on various subjects. The books are written by authors who specialize in one particular subject. The company employs editors who, not necessarily being specialists in a particular area, each takes sole responsibility for editing one or more publications. A publication covers essentially one of the specialist subjects and is normally written by a single author. When writing a particular book, each author works with an editor, but may submit another work for publication to be supervised by other editors. To improve their competitiveness, the company tries to employ a variety of authors, more than one author being specialized in a particular subject. So this is an example. I need you uh, to give me some entity. You should be able to take out some entity from this example. Any one of you want to talk, or you can type uh, some. You can type in chat window some entity that you find. We said entity is anything that we need to uh, store some information about. Mr. Barak said authors, book company. Good, very good. Authors can be an entity or a company. Actually, it's a specific company. So author accepted can be an entity. Editors also an entity. We need subjects. Good, subjects can be an entity. Very good. The others, in a database, the first thing, actually before programming and anything, we need to find the entities and find the relationship, actually the relationship between this entity in our database. And uh, there is some actually technique for designing the database, and after designing we need to program everything. One of this designing, we call it entity relationship or ER relationship. As you see here, actually we have ER criteria. ER stands for entity relationship. We need to find the entities and their relationship. So the answer is here, as we mentioned: author, subject, publication, editor, author, editor. These are some of the entities and they have some relationship. The other example is here. It's a hospital. In hospital, we also need to have a database. I read it for you. A general hospital consists of a number of specialized wards such as maternity, pediatry, oncology, etc. There is some specialists. Each ward hosts a number of patients who were admitted on the recommendation of their own GP and confirmed by a consultant employed by the hospital. On admission, the personal details of every patient are recorded. A separate register is to be held to store the information of the tests undertaken and the result of a prescribed treatment. A number of tests may be conducted for each patient. Each patient is assigned to one leading consultant, but may be examined by another doctor if required. Doctors are specialized in some branch of medicine and may be leading consultants for a number of patients, not necessarily from the same ward. This is another example. I need you to find some entity in this example. We need to design a database for a hospital. Ward, very good. Patient, consultant, Mr. Barak, test, doctors, medicine, and Mr. Jawad said wax. Very good. Good. We can see the answer together. Here is answer for this question, for this example: wax, patient, GP, test, test result, treatment, diagnosis, doctor, consultant. And there is some relationship based on the scenario that is given. There is some relationship. And this is more detailed, actually, relationship. Full answer. Okay, these two examples, one for the hospital and one for a publication company. So, first step is to find our entities, then design our database, and after that we need to actually coding, do some programming, and create actually our database. So database technology cuts through many of the problems of traditional file organization. We said we need something to get rid of that problems. This database can help us to actually solve the problem of traditional file environment. Actually, we can define a database as a collection of data organized to serve many applications efficiently by centralizing the data and controlling redundant data. Besides, rather than storing data in separate files for each application, data are stored in only one location, a a single database services multiple applications. For example, an employee data. Here you can see a database management system. These are some employee data: employee ID, employee name, number, position, net pay, healthcare, everything uh, about an employee. So we define database as a collection of data organized to serve many applications by through centralizing data and controlling redundant data. Centralizing data, everything is centralized. All the data is centralized. All this to help us to solve the problems. Actually, redundancy, inconsistency, sharing problems, security. We need to have some centralized data, some uh, controlling to control redundancy and all these problems that this system help us. So, this is definition of database. What is database management system? Actually, database management system is an interface, is a software that is actually acts as an interface. It's a software which is interface between the application program and the physical data files. So, database management system is as you can see here, is the interface between application program and physical data files. We have different view here. So we as a user can see the logical view, and the technical person who built the database can see the physical view behind this logical. We do not need the actually the physical view. That one is for the IT mans and for the specialists in this area. As a user, you can see a logical view. You can work with this database management system actually. For example, uh, human resource database, we can have a different view. In this graph, you can see there is a human resource database here. Database management system is it? Can you see here? Database management system. It's an interface. It's a middleman here. So we can have different view. We can have different usage. Here is from the benefits view. Here is from the payroll view. The database collect the employee data. For example, this one just need the name, SSN, and healthcare. But here we need name, SSN, gross pay, and net pay. So we have one database, one centralized database for human resource, and we have different usage. We can use actually multiple view from this database. So I hope you can, by now you can differentiate between database and DBMS. Database, we centralize, we collect all our data in the database, and but DBMS is a software. It's a actually software. It's the interface between the application programs and between the physical data. So, and we said DBMS solves the problem of traditional system, traditional file environment by reducing the data redundancy and inconsistency, actually by minimizing isolated files in which the same data are repeated. It's try to uh, maybe database is not able to eliminate the redundancy entirely, but can help to control the redundancy. But DBMS can ensure the elimination of the data inconsistency. The DBMS enable the organization to controlling, managing data, their usage, and their security and everything. So, in order to this, database management system needs to have some capabilities. You can see here in this slide the capabilities of DBMS as a data definition capability, data dictionary, data manipulation language, and report generating capabilities. These are some capabilities that DBMS need to have in order to solve the traditional uh, traditional file architecture problems. You can see here data definition capability actually specified structure of database content used to create tables and define characteristics of fields. Data dictionary, automated or manual file storing definition of data elements and their uh, characteristics. Data dictionary is collecting the data. Uh, you can see how to say data dictionary collecting data. Actually, we can say collecting data about the data. For example, we can see we can have a name, description, size, type, format, and other properties of or field about the data. These are some characteristics of data that data dictionary help to collect. It's one of the powerful capabilities of DBMS. The other things is data manipulation language. This one used to add, change, delete, retrieve. Actually, when we go to after designing our database, we need to program it to code it. This manipulation language like SQL, like Microsoft Access, uh, like Oracle, different databases, database languages actually help to uh, implement our uh, designing, our database design. And many DBMS have report generation capabilities for creating polish reports, like Crystal reports. You may be familiar with Crystal report. It's for generating the reports. It's a part of, actually, it's a capability and it's a tools in DBMS systems. So here you can see uh, Microsoft Access Data Dictionary feature. For any of our attribute or characteristic, we have some special characteristics here. This one is an example of Microsoft Access, or here we have an example of SQL query, as we said, Crystal report or something like that can give us some query or report. Here you can see there is a query. It's actually it's a language, SQL language you need to program. For example, and this one is one of the commands: select part, point part number, point part name, supplier, point supplier name, and supplier, point supplier name, from part and supplier. Part and supplier here are two entities in this uh, database. By using the select command, we want to take part number, part name, supplier number, and supplier name from these two tables, from these two entities in our database, where the static in the way that the supplier name equal to uh, supplier number and part number is equal to 137 or part number 150. This one is a SQL command or statement which selects supplier for part number 137 and 150 from this. Actually, this command using two entity, using two table, part and supplier, mix these two entity to table together in order to get the supplier number and for these two part number. Okay, this one is an example of SQL, which is a language for implementing the database. So here you can see this query, same query, but in the Access, not SQL. SQL, you know, we need to type our command, but in Access, it's a user-friendly interface. It's one of the Microsoft programs, but you can see the same query here: part number, part name, supplier number, supplier name, and we have a criteria here to show the part 135, 137 or part number 150, and these two entity, part and supplier, and this one show the relationship between these two entity, two table in our database. So we talk about centralizing the data, designing the database, and implementing the database. We talk about different view: logical view, physical view, and the relationship between the tables, between actually each table in database show one entity. We talk about the entity and their relationship in our database. Businesses use this structure, this database, to keep track of business transactions such as paying supplier, processing order, keeping track of customers, and paying employees. But they also need databases to provide information that will help them actually help their company to run their business more efficiently. They need some and actually they need some tools or some softwares to help their employees, especially their managers, different level manager, in order to make better decisions. If a company wants to know, for example, which product is the most popular or who is the most profitable customer, the answer lays on the data. So in large companies, with large database or large system, businesses need to have some set of capabilities that we talked about, and now they need to have some tools or capability in order to be able to analyze the data. These capabilities can be data warehouse, can be data mining, and some actually tools for accessing internal database through the web and something like this. We can see here, large company need these tools. But before going more details and about these things, there is we talk about some slides here that talk about uh, summarizing the things I have told. It's an entity relationship diagram. We also had something like this in the tutorial file. You know, here we have order, we have supplier here, and the order part and the line item, something like this. This one showing a part of an entity relationship and design actually. So come back here. Till now, we find about databases. We get some information about database and the different concepts and components of the database. So now businesses, organizations need to actually use these databases to analyze the large quantity of data, to access data from multiple systems. There is some techniques, some tools for them to analyzing these things. Some are such as data warehousing, data mining, or tools for accessing internal database through the web, or we can call it web mining. So, what is data warehouse? Data warehouse actually is a, it's a kind of database that collects the current and historical data. When we say data warehouse is a database, but it stores current and historical data in order to for decision makers through the organization. Actually, this data can be about a different part of our organization. The data warehouse, you need to see it as a huge database that collect the actually save and store the data, our organization data for a long time in data warehouse. We have a database that work with it, do the day-to-day activities, and we have a warehouse which is a very big, very huge database that store also our historical data. Imagine, for example, uh, mm, for example, mm, take a bank as an example. So there is different customer and they have some records, some information in the bank database. They have some day-to-day transactions, transferring money, paying bill, doing something like this. So all this activity is stored in database and in daily transactions. But for example, uh, for one customer, uh, bank may not need to have everything about this customer in, in their operational transaction system database. They need some places to store uh, mm, information about this customer. For example, 2 years 2 years ago transaction, 10 years ago balance, or something like this. The historical data about this customer, this specific customer, stored in data warehouse. For all the customers, all the historical data, historical information stored in data warehouse. And in any cases, maybe the customer wanna know his information, his some transaction in 5 years ago. On that time, we can refer to data warehouse and get the information in order to evaluate, to analyze it, and to uh, actually make a decision. The other thing is this data collected, for example, in merchant, in retail industry, in automotive industry, in different industry, this historical data gives some pattern, some movement, and help to analyze the business process, analyze the customer activity and everything. You know, these days in the business economy, big organization, huge organizations use their databases in order to actually for forecasting and for something like this. They help actually this data warehouse helping their organization. And what is the data marts? Actually, data marts is a subset of a data warehouse. It's a it's a particular part of data warehouse which talk about some specific thing, a specific area, and focus on a single subject. As you can see here, typically data marts focus on a single subject or line of a business. But imagine the warehouse as a very huge database that collect all the historical and current data. Here in this graph, in this example, I try to make it more clear for you. You know, in an organization, we have some internal data sources and some external data sources. Internal data sources like operational data, customer data, manufacturing data, historical data, and also uh, we have some external data. So all this data get together, extract, and transfer to data warehouse. And data warehouse, since uh, lots of information collected in the data warehouse, of course we need a information directory, and based on some tools like OLAP, like data mining, queries and reports, we use database in order to analyze the data and help the managers and organization to make decisions. So we have concept of business intelligence. All these things, data warehouse, data mart, data mining, OLAP, all these things lead us to a business intelligence. Actually, business intelligence, once data have been captured and organized in a database, in data warehouse, and in data mart, they are available for further analysis. So using some business intelligence tools help the companies and enable the users to analyze data, to see the new patterns, to see the relationship, and in order to help them to have an insight that are useful for guiding decision making and for maybe forecasting, for everything related into develop and to increase, to enhance our business. Principal tools for business intelligence include software for database querying and reporting, or tools for multi-dimensional data analysis, and tools for data mining. So you can see the principle here: software for database query and reporting, online analytical processing or OLAP, and data mining. Business intelligence these days, uh, considering by uh, big organization as a necessity, as a these business intelligence tools help them to find more information about their customer, to find some pattern and relationship in their organization. A very interesting example and case study in this, uh, you know, business intelligence is a case of Harald Entertainment. Harald Entertainment is the second largest gambling company in the industry. They continually analyze data about its customer, gather when people play its slot machines or use Harald's casinos and hotels. Harald's marketing department use this information to build a detailed gambling profile for each customer based on their uh, particular activities, booking, playing, and something like this. This information got management decisions about how to cultivate the most profitable customers, encourage those customers to spend more money, and also attract more customers with high revenue generating potential. Business intelligence has improved Harald's entertainment profits so much, considerably improved their profit, um, that it has become the centerpiece of actually this business intelligence become their centerpiece of the firm business strategy. So business intelligence is very important these days, and the base of business intelligence is data. Data needs to be collected, needs to be captured, needs to be centralized, uh, actually in such a way that efficiently can be a mm, source for business intelligence tools in order to help the organizations to in decision making and in forecasting and finding the pattern and relationship. So we're going to talk about some of these principles, for example, OLAP or data mining. In the next slide, uh, you know, uh, please make note that we talk about the multi-dimensional actually tools, multi-dimensional data analysis tools. OLAP, online analytical processing, is a multi-dimensional. So here in this graph, you can see we have different databases, and we have data warehouse here. There is some tools, OLAP, data mining, and query reporting, and business intelligence. In database, we just keep track of transactions. In data warehouse, by these tools, we find patterns and insights about the data in our organization. And we use all these things in our business intelligence tools in order to decision and to respond to the patterns and take some beneficial action and activity uh, in the organization. So OLAP, or online analytical processing, as I said, it supports multi-dimensional data analysis, viewing data using multi-dimension. In next slide, I bring you an example. In this graph, for example, we have a company that produce and sell the nuts, bolts, washers, and screws. The other dimension is the region. We have east, west, and center branches, different branches in east, west, and central. And we have something like actual and projected. We have some projected plan for sailing for something, and we have some actual. This example, as you can see, uh, show the different dimension. As I said, OLAP is a multi-dimensional application, actually multi-dimensional data analysis can help the manager to solve the more complicated situation and more complicated, problems. So, sorry. You know, uh, Traditional database queries can answer such question like how many units of this special products these nuts, for example, were shipped in February 2011, for example. But OLAP or multidimensional analysis support much more complex requests for information, such as compare sales of product, nut or bolt relative to plan by, uh, for example, quarter and sale region, something like this. OLAP can analyze the data based on 3 dimensions. How many nuts were sold in West, actually in a specific time period, and we can compare the actual and projected. We projected something, we planned something, but the actual is different. From 3 dimension, we can analyze the data. This is OLAP, which is one step further than the traditional database. So after this one, we have data mining. Data mining also give us, more discovery driven. Data mining is more discovery driven. Data mining provides insight into corporate data that cannot be obtained by the traditional database or by OLAP. But data mining try to uh, find some pattern and also some relationship in the database and inferring rules from them to predict future behavior. Data mining is a more complex system that can help the organization and businesses in order to predict the future behavior. As you can see here, find some hidden pattern relationship in a large database and rules to predict future behavior. So, and here is types of information obtained by, data mining: association, sequence, classification, clustering, forecasting. These are some source of information that we can obtain by data mining. For example, when we say association, we try to relate some activity together. For example, let me bring you some example, some very simple example. For example, and a supermarket uh, selling um, potato chips or French fries. Uh, the amount of or the quantity of this potato when sold, for example, based on the analyzing the data, we find it that uh, 60% of these potato chips in 60 times people buy some ketchup with potato, with when they based on the analyzing and the data in the association part. We find out then when the people buy 60% of the people when they buy chips, they also buy ketchup. So this one helps manager to in, for example, in positioning or anything. The other one is, for example, sequence. We can find out from the data analysis, from the data mining, when the houses sold, the rate of increase and the rate of number of house sold during a year increasing. With this one can be result in selling the furniture. These are all the uh, some information, some data that help the organization to predict the future. The number of house sold, then after that, so the people needs furniture. And the other thing is classification. For example, we can, based on the analyzing the data, we can classify the customers based on, for example, their credit card. Based on something, we can classify them, or we can clustering them, for example, based on the geographical uh, region or geographical place they live, or based on some specific brand or something like this. We can cluster the information, or we can even have forecasting. We can find some pattern which help the organization, help the business in order to have a accurate forecasting about their future, for example, about the amount of sale or something like this. So data mining uh, give more discovery, about the data, analyzing the data, and help the company, help the businesses um, in order to uh, evaluate the market and evaluate the economy and make a better decision for their future activities. So the other thing is we talked about, it was web mining. We need to have some tools that's from the outside, from the web pages. We can from the internet, we can go to our website. These days you use online banking. So I, as a customer, uh, at my home, using my computer, and go to the bank database. When I log into my account and do some, for example, paying my bill, transferring money, reload my mobile phone, do anything, any kind of activity. So my information is in the bank database, but through web, through the web page, their web page from my home, I can reach to their database, can access to their database. We call this one as a data mining. And as you know, all the businesses and organizations these days have their own website, have their own databases, Google, Amazon, Facebook, any company or organization or website you can mention here, they have their website and their databases and their online applications. So web mining discovery and analysis of useful pattern and information from World Wide Web, understand customer behavior, evaluate effectiveness of website. They have some special technique for this thing: web content mining, web structure mining, and web usage mining. So we go uh, through this thing very fast. Database and the web. Many companies use web to make some internal database available to customer or partners. As I bring an example, like online banking, as I talk about it, it's also mentioned here. They provide me as a customer with some uh, with their website and their database. I can access to my account and, for example, transfer my money to others, can uh, actually pay my bills or do any kind of activity. So typical configuration include web server, application server, database server. So they uh, they establish the infrastructure for me as a customer to be convenient and in order to retain me as their customer. Advantages of using web for database access: ease of use of browser software. Web interface requires few or no changes to database. Inexpensive to add web interface to system. Here you can see linking internal database to the web. I'm here as a client, as a customer at my computer, go through their website through internet. First, I connect to a web server, then application server, then database server, and finally database. My information in the bank, in their database, I can access through internet. So this graph showing the linking internet databases to the web. So we talk about database, collecting the data, and analyzing the data. Some tools: OLAP, data mining, data warehouse, web mining, everything. Talk about data and information, and also we need to have some policy and some rules and procedure uh, to keep our data and data governance and data activity, and provide the accurate data and check everything out. You know, for example, here in this slide, we can see establishing information policy, firms, rule, procedure, roles of sharing, for sharing, managing, standardizing data. For example, what employees are responsible for updating sensitive employee information. You know, uh, since this data going to be very critical for the organization and businesses these days, we need to have some policies, some data administration, data governance, database administration policies. Data administration firm function responsible for specific policies and procedures to manage data, or data governance policies and processes for managing availability, usability, integrity, and security of enterprise data, especially as it relates to government regulation. And database administration: defining, organizing, implementing, maintaining databases, performed by database design and management group. Ensuring data quality: more than 25% of critical data in Fortune 1000 company databases are inaccurate or incomplete. So we need to be ensure about the data quality. Most data quality problems stem from faulty input. So this one need to be considered. Before new database in place, need to identify and correct faulty data, establish better routines for editing data once database in operation. So these are some things related to enhancing the quality, the data quality actually. Data quality audit, structured survey of the accuracy and level of completeness of the data in an information system. Survey samples from data files or survey and users for perception of quality. Or, for example, data cleansing software is a kind of software to detect and correct the data that are incorrect, incomplete, improperly formatted, or redundant. So there is a software here helping to you know, auditing and uh, enhancing and increasing the quality. Enforces consistency among different sets of data from separate information system. And thank you all for your attention during today's class. I hope you get some insight about the database and uh, its importance in business economy these days, especially the business intelligence. You need to uh, know more and more about the business intelligence, and you can do some research about business intelligence and the infrastructure and the base for business intelligence is database. So managers and IT specialists need to work together in order to enhance and actually first of all implement and then enhance their databases and mm, put some using some business tools, some intelligence tools in order to analyze the data to help them find the trends and the market patterns and forecasting their future. So this this was a lecture about the actually foundation of business intelligence, databases, and information management. Thank you all for your attention. If there is any question, please do not hesitate to ask. We still have some time. We can have some question and some discussion about these things. If there's any question, please do not hesitate to ask. If not, I wish you all a good night and goodbye.